welcome to another module in this massive open online course. So, we are looking at angle modulation, which comprises of basically two kinds of techniques, either phase modulation and frequency modulation. We have looked at the different kinds of we have looked at the properties of frequency modulated signals, alright, and also representations of frequency modulated signals. So, in this module, let us start looking at the generation of frequency modulated signals, alright. In particular, let us start with the generation of narrowband frequency modulated signals. Okay. So, what we would like to do is we would like to start with a discussion of generation of frequency modulated signal. In particular, let us start with a simplistic scenario where we have narrow band, where we consider narrow band FM signals, narrow band. So, we want to look at narrowband FM signals and we want to look at narrowband FM generation in particular. Okay. So, basically we want to look at the generation of narrowband FM signals. And in this we will start with a technique known as the indirect method for narrowband FM signal generation. Okay. So, consider the message signal. So, let us say consider the message, let us say we have the message signal. MT equals AM cosine 2 pi FMT. This is our message signal. Okay. So, we are considering the message signal AM cosine 2 pi FMT towards illustrating this process of generating a narrowband FM signal. Alright. Okay. Now, let the modulated FM signal be we have already seen that the modulated FM signal is ST equals, since this is a sinusoidal modulating signal, we already seen the corresponding modulated signal A cosine 2 pi FCT plus beta sine 2 pi FMT. This is your modulated signal, correct? So, this is basically the modulated signal, and what we have seen is this value beta, the value of this modulation index beta for this scenario is KF AM divided by FM, which is basically your delta F divided by FM. So, this is your modulation index beta, okay, that also we know. So, this is your the modulation index beta. Okay. So, now we would like to generate a narrowband FM signal. Let us consider a signal in which this modulation index beta is very small. All right. Later we are going to describe how to generate an FM signal where beta is not very small, or beta has some nominal value. Okay. So, to begin with, let us consider a scenario with very small beta, that is the modulation index beta. All right. So, to begin with, consider beta significantly less than 1. This implies that basically your delta f by Fm, beta is delta f by Fm is significantly less than 1, which implies delta f is significantly less than Fm. Now, this is termed as a narrow band Fm signal. This is termed as a narrow band Fm signal, that is a signal for which beta is significantly less than 1, that is beta is very small. This can be considered as a narrow band FM signal for the reason that the spread, the bandwidth occupied by this signal is going to be very small, as we are going to see when we discuss the bandwidth of an FM signal. Alright. So, when beta, this modulation index, is very small, the bandwidth occupied by the FM signal is indeed very small. Okay. So, we call such an FM signal a narrow band FM signal. Okay. And now, this narrow band FM signal, for this narrow band FM signal, for such a narrow band FM signal, we have, now for such a narrow band FM signal, now for such a narrow band FM signal, we have St equals A cosine 2 pi FCT plus beta sine 2 pi FMT. Now, this can be simplified for using the properties of the cosine function as using the trigonometric properties, that is A cosine A plus B cosine A is cosine A cosine B minus sine A sine B. So, this is cosine 2 pi FCT cosine beta sine 2 pi FMT minus AC sine 2 pi FCT into sine beta sine 2 pi FMT. Alright. So, we have simplified this modulated signal AC cosine 2 pi FCT plus beta sine 2 pi FMT. Okay. Now, we are going to employ the property, that is for small beta, that is for small beta we have, well, for small beta cosine beta sine 2 pi FMT, this is approximately equal to 1, because beta is small. So, cosine theta is small. For small theta, cosine theta is approximately 1, and for small theta, sine theta is approximately equal to theta. So, employing this approximation, sine of beta sine 2 pi FMT is approximately equal to beta sine 2 pi FMT. For small theta, sine theta is approximately equal to theta. So, therefore, sine beta sine 2 pi FMT is simply beta, approximately beta sine 2 pi FMT. Now, when we substitute this in the expression, so substituting these, so now substituting these in the expression for the modulated signal XST. So, what we are going to do is we are going to substituting these expressions in the relation or in the expression for the modulated signal xt we have st equals, well, a cosine 2 pi fct, a cosine 2 pi fct into cosine beta sine 2 pi fmt, that will be 1, since, so what we have here is this cosine beta sine 2 pi fmt, this is approximately 1, and sine beta sine 2 pi fmt is approximately equal to beta sine 2 pi fmt. So, substituting these, we have AC cosine 2 pi, this is approximately equal to AC cosine 2 pi fct 1 minus A sine 2 pi f, that is sine 2 pi fct into beta sine 2 pi fmt, which is equal to A cosine 2 pi fct minus beta sine 2 pi fmt into sine 2 pi fct, and this is the approximation for your narrow band modulated. So, this is basically we are going to employ this approximation for the narrow band modulated FM signal. So, this is an approximation, this is the approximation for this is the approximation for the narrow band, this is the approximation for our narrow band modulated FM signal, and we are going to employ this approximation for the generation of the FM signal. And you can see it is reasonably simple with this approximation, because now the modulating signal is out of the phase component and it is in the form of a product of the carrier and the message signal, right. So, you can see this is basically in the form of a product, that is sine 2 pi fmt into sine 2 pi fct. So, now basically we can generate this narrow band. So, now you can generate this narrow band modulated FM signal. So, this can be employed to generate the, so, and this approximation can be employed. So, this approximation can be employed for this approximation can be employed for narrow band FM generation. So, let us look at how to generate that. So, I have MT, which I can basically, this is your message signal, I can basically pass it through an integrator, right, correct, that is your cosine 2 pi fct, that integrate gives sine 2 pi. So, I can pass this it through the integrator, correct. So, this is, let us say, your AM, this is your AM cosine 2 pi fm t. You pass it through the integrator. At this point you will have, so you will have integral 0 to t am cosine 2 pi fm t. At this point you will have am cosine 2 pi fm t integral 0 to t am cosine 2 pi fm t, which is basically equal to, well, this is am divided by 2 pi fm sine 2 pi fm sine 2 pi fm t. So, this you multiply at this point, you multiply this by, will you multiply this by 2 pi into kf. So, you multiply this by 2 pi into kf. So, you take the output of the integrator multiplied by 2 pi into kf, first multiplied by this factor 2 pi into kf, and also multiplied by this multiplied now this is basically multiplied by this, so that gives you beta. So, this gives you basically your beta sine 2 pi fm t, which at this point you multiply by you modulate with the cosine signal, that is AC cosine or AC sine 2 pi fct AC sine 2 pi fct, and so you have this AC sine 2 pi fct which can in turn be generated by a 90-degree phase shift from a cosine modulator. So, I have a cosine modulator which is generating your oscillator rather. So, this is your AC cosine 2 pi fct, and this signal, let us say, and this signal you add this over here. So, you have AC cosine 2 pi fct minus or you have A cosine 2 pi fct minus, and let us say I have this minus 2 pi kf. So, this will be minus beta sine 2 pi fmt times A sine 2 pi fct. So, what you have here will be the narrowband FM. So, this will be your narrowband FM. The output of this will be your narrowband FM. Okay. So, this is basically your schematic diagram or diagram of narrowband FM generator. Okay. So, this is basically your diagram for the this is the diagram of your narrowband FM, a diagram of a simple narrowband FM generator. So, I am taking AM cosine 2 pi FMT, passing it through an integrator that gives me am by 2 pi fm sin 2 pi fm t. So, multiplying that by 2 pi kf or minus 2 pi kf, that gives me, so minus beta sin 2 pi fm t, that will be the output here. So, this is modulated through this a sin 2 pi f c t, alright, and the same thing is also again to the same thing we add a c cosine. So, you have at this point or at this point you have a sin 2 pi f c t or minus beta a sin 2 pi f c t into sin 2 pi f m t, that is what you have at this point. So, minus beta sin 2 pi f m t sin 2 pi f c t, that is what you have at this point. To that you add a cosine 2 pi f c t, and that gives you your narrowband FM signal. So, this is basically the narrowband FM generator, alright. This is a simple schematic diagram for the narrowband FM generator, alright. So, in this module what we have seen is we have technique to generate the narrowband FM signal. We have seen that the narrowband FM signal is a signal for which the beta, that is the modulation index beta, is significantly lower than 1. That so, using an approximation for that, right, a reasonable approximation for this scenario when beta is much less than 1, we have simplified this expression for the modulated narrowband FM signal, and based on this approximation for the narrowband modulated FM signal, we illustrated a simple scheme to generate this narrowband FM modulated signal, alright, by modulating the signal appropriately with integrated version of the signal appropriately with sin 2 pi FCT and adding the cosine carrier, that is cosine 2 pi FCT, alright. So, we will stop here and continue with other aspects in the subsequent modules. Thank you very much.